Hi everyone, welcome to our Python 10 project presentation. Our project is a gun detection with Python programming. Team members are
Merve Polat
and I'm Aleyna Narin. In our gun detection project, we use YOLO version 5 and the RoboFlow API to train and test an object detection model. YOLO version 5 is a real-time object detection model that is fast and accurate, making it a suitable choice for this project. We use the RoboFlow API to set up project environment, download a dataset, and train the model. We run our code on Google Colaboratory, a cloud-based platform for running and sharing Jupyter notebooks, which allowed us to easily access and use the necessary tools and resources. We trained the model on the dataset and then used it to detect guns in images. The results of the detection were displayed on the screen, allowing you to evaluate the performance of the model. Overall, this project demonstrates the use of advanced techniques and tools for building and deploying an object detection model for gun detection.
What's our scope? The scope of our gun detection project is to build and deploy a model using YOLO version 5 and the RoboFlow API that can accurately detect guns in images. This includes setting up the project environment, downloading the dataset, training the model on the dataset, and using the trained model to detect guns in images. The project also involves running the code on Google Colaboratory and displaying the results on the detection on the screen. One potential area of focus within the scope of this project could be to optimize the performance of the model, for example by fine-tuning the model's hyperparameters or using a larger or more diverse dataset. Another possible focus could be to integrate the model into a larger system or platform, such as a security camera system or a mobile application, and to test its effectiveness in that context. Additionally, the project could involve exploring different applications for model, such as using it to detect guns in videos or to assist with military or law enforcement training simulations. Project's benefit and importance. Object detection models like the YOLO version 5 can be useful in a variety of situations where it's important to accurately identify and locate objects in images or videos. Some possible applications of such models include security and surveillance, self-driving cars, and robotics. In the case of our gun detection project, the model could potentially be integrated into security systems to automatically detect and alert authorities to the presence of guns in public spaces or private homes. It could also be used in military or law enforcement training simulations to improve accuracy and efficiency in detecting and responding to threats. In general, object detection models like YOLO version 5 can be integrated into a wide range of the systems and platforms, including mobile devices, web applications, and standalone software. The use of APIs like RoboFlow can make it easier to set up and manage these projects, as well as to access and use datasets for training and testing. Overall, object detection projects like ours can be highly useful for beneficial in a variety of settings and industries. YOLO version 5. It stands for You Only Look Once. YOLO version 5 is a real-time object detection model developed by the Ultralytics team. It's a neural network-based model that is trained to detect and classify objects in images and videos. YOLO version 5 is fast and accurate, making it suitable for a wide range of applications where real-time object detection is important. It's an evolution of the original YOLO model, which was introduced in 2015. YOLO version 5 has been designed to be easier to use and more performant than previous versions, and it includes a number of innovations and improvements such as efficient net backbones and SPP-net architecture. YOLO version 5 is implemented in PyTorch and is available for use in various projects through the Ultralytics GitHub repository. RoboFlow. What's RoboFlow? RoboFlow is a platform that provides tools and resources for building and deploying machine learning models, with a focus on computer vision tasks such as object detection and image classification. It offers a range of features including data annotation and augmentation, model training, and evolution and integration with cloud-based platforms like Google Cloud and AWS. RoboFlow also provides an API that allows developers to access and use the platform's functionality in their own projects. RoboFlow is designed to make it easier for developers to build and deploy machine learning models, particularly in the field of computer vision. It provides tools and resources that can help with tasks such as data preparation, model training, and evolution and deployment. RoboFlow is particularly used for developers who are working on object detection, and image classification projects, as it provides a range of tools and resources that are tailored to this task. Why is Python used for object detection? Python is a popular choice for building object detection models because it's a high-level programming language that's easy to learn and use. It has a large and active community of developers, which means there are many libraries, frameworks, and tools available that can be used to build object detection models and related systems. Some examples of these libraries include PyTorch, TensorFlow, and OpenCV. These libraries provide a range of functionality that is useful for building object detection models, including support for neural networks, image and video processing, and parallel computing. In addition to its rich ecosystem of libraries and tools, Python is also highly flexible and can be used to build object detection models for a wide range of applications and platforms. Data collection part. Data is a critical component of object detection models. It is used to train and test the model, and the quality and quantity of the data can significantly affect the performance of the model. Data for object detection typically consists of images or videos that have been annotated with labels indicating the presence and location of objects of interest in the image or video. Data collection for object detection involves acquiring or creating a dataset of labeled images or videos that can be used to train and test the model. How did we do our data collection part? As you can see, there is handgun folder, and we collect so many images. Data labeling. Data labeling is the process of annotating images or videos with labels that indicate the presence and location of objects of interest in the data. The quality and accuracy of the labels has a direct impact on the performance of the model, so it's important to ensure that the data is labeled correctly and consistently. This is RoboFlow, and we labeled our handguns like that. And also, as you can see from these pictures, and we upload our all images and we label them. Here's our code. First of all, we installed a weapon sensor YOLO version 5 with these commands. We clone it on Google Collaboratory. We import Torch and import OS. We activate RoboFlow and download our data in RoboFlow. We set our environment in order to operate. We copy the API code we received from RoboFlow, and it will download when it runs. We start the training of the model. Our image was 640,640, and they were trained in 100 epochs in best of 16. As you can see, epoch 0, epoch 24, epoch 99, and finally epoch 100. We print the success rate of the model on the screen in the form of graphs. We are launching our TensorBoard. Here is our graphs. We are trying to train our test data. We insert our test image into the model, and the results are saved in the file location. We print the final version. We import glob. Our test data results is like that, and our handgun is labeled like 0.88 and 0.84, 0.54, 0.59. And you can see our links and references. OpenImage dataset is a platform that you can download so many photos. And RoboFlow is a website that we can label our data. And this is our Google Collaboratory links that our code is here. And thank you for listening. This was our Python project.
Thank you.
I hope you enjoy it.